You ever wonder how something like a smart water meter, way out in a field somewhere, can send data for years without anyone ever changing its battery? Or how a sensor on a shipping container crossing the ocean does the same thing? Well, the answer is this really cool piece of tech that's kind of quietly powering the whole Internet of Things. So let's get into it. Let's talk about LoRaWAN. So what is LoRaWAN exactly? Well, at its heart, it's a protocol that's built for one very specific job, connecting small, battery-powered devices to the internet over huge distances. Now, the two keywords you gotta remember here are low power and wide area. This isn't like your home Wi-Fi or Bluetooth, not even close. It's built from the ground up for massive efficiency and incredible range, which, as you can imagine, is absolutely critical for the millions of sensors that make up the IoT. Okay, I know this diagram might look a little complicated at first, but trust me, it's actually a super logical and pretty elegant system once you see how it fits together. What we're going to do is break it down into its four main parts, starting with the sensors out in the world and working our way to the brains of the network. By the end, you'll see the entire journey a tiny piece of data takes, from a physical object all the way to an application on your screen. All right, part one. The things on the edge. We're going to start at the very edge of the network with the devices that are actually out there, in the real world, collecting all that information. So our first element is the end device. This is literally the thing in the Internet of Things. You can think of these as the hands and the ears of the entire network. These devices can be something as simple as a gas monitor or a smoke alarm, or they could be actuators, things that can actually perform an action, like shutting off a valve. And here's the key. They are almost always running on a battery. That's exactly why that low power feature is so important. They use a special radio signal called LoRa to wirelessly send their little packets of data out into the world. Now, what's really cool is that not all these devices are the same. LoRaWAN actually has three different classes. Class A is the king of power saving. It sends data and then listens for just a tiny moment for a reply. Class B devices wake up and listen at scheduled times, and Class C devices are pretty much always listening. So you get to choose the right class for your needs, basically trading battery life for how quickly you need a response. It's a really smart system. Okay, so our little end device has sent its message, but where does it go next? Well, it travels into the core infrastructure of the network, which is what we're going to look at now. The next stop on our data's journey is the gateway. You could call this the unsung hero of the whole LoRaWAN network. It's the critical bridge between the device and the internet. So a gateway, or a concentrator as it's sometimes called, does one thing, and it does it really, really well. It just listens for LoRa messages from all the end devices in its range. As soon as it hears one, it grabs it and simply forwards it on using a standard internet connection. We're talking regular stuff like cellular or Wi-Fi. What's amazing is that a single gateway can handle messages from thousands of different devices, and that simplicity is what makes the whole network so easy to scale up. All right, once the data is on the internet, it arrives at the brain of the whole operation, the network server. The network server is basically the air traffic controller for the entire network. It manages, well, everything. It's the bouncer at the door checking to make sure a device is authentic. It filters out any duplicate messages that might have been picked up by a few different gateways, and then it routes the data where it needs to go. Now, the server doesn't care what the data is. It just makes sure the right envelope gets delivered to the right mailbox securely and efficiently. And finally, our little data packet has reached its last stop. This is the place where it gets turned from just raw data into something genuinely useful. The application server is where all that data's potential is finally unlocked. So, if the network server was the super secure postal service delivering a sealed envelope, the application server is the person who gets to open that envelope and actually read and act on the message inside. This is where a simple temperature reading gets displayed on a dashboard or is used to trigger an alarm. This is where data becomes information, and information becomes action. So, we've met the four key players in the network. Now let's put it all together and actually trace the path of a single message from the very beginning to the very end. Okay, so let's follow the data. Imagine that gas monitor out in the field. It detects a reading and sends out a tiny, low-power LoRa packet. That packet is then picked up by one, or maybe even several, gateways. They instantly forward it over the internet, where it arrives at the network server. The server validates it, gets rid of any duplicates, and routes it to the right application server. And it's that server that finally processes the reading and shows it to you on a screen. See? It's a completely seamless journey. When you boil it all down, the real magic of this entire system comes down to this one incredible fact. The idea that devices can last for a decade on a single small battery, that's not just a small improvement. That is a complete game changer for what we can connect and monitor in our world. And that kind of leaves us with a final thought, doesn't it? We now have the technology to build these huge sensor networks that can last for years, watching over everything from our cities and farms to our environment. The question isn't really if we can connect something anymore. The question is, what should we connect? With this kind of power at our fingertips, what are we going to choose to build next?